Hello and welcome to this webinar on PatSeer. In this webinar, we will cover PatSeer's exciting new AI search capability, and with the help of case studies, we will also see how the AI search can help you in various IP research tasks. A quick note about the presenters of today. My name is Manish Sinha. I am the Chief Technology Officer at PatSeer. I have more than 18 years of experience in patent research and analysis. The second presenter is my colleague, Ankita Oval. She's a customer success executive at PatSeer. She has close to about 7 years of experience in the patent domain. And she works with PatSeer's users to ensure that the product is helping them in their day-to-day IP objectives. Quickly going into today's flow of the webinar, we are going to begin with understanding how the evolution of search has been in PatSeer. We will go further to understand what does LLM-based AI search or GPT-powered AI search really mean. Further, we'll take a look at how the older NLS approach, NLS meaning natural language search, how does that compare with LLM-based semantic search? We will then quickly deep dive into the PatSeer application and take you through the PatSeer's AI search UI and the various functionality around it. Finally, we'll move on to the key part of today's webinar, which are the case studies, and we will go through various case studies ranging from patentability assessment and right till invalidity assessments. Before going into the AI-based search, let's take a quick look at the evolution of how search has evolved within the PatSeer platform. Being a professional search platform, we started off with the Boolean-based searching, and our initial search relevance, or the logic that decides how the search results are placed against your input Boolean query, was based on the TF-IDF algorithm. The TF-IDF algorithm stands for term frequency, inverse document frequency, and in very simple terms, the algorithm rewards documents that have higher term frequency and penalizes those words that come across a large number of documents. This was further enhanced to the BM25 logic later. BM25 is an enhancement over the TF-IDF. It accounts for the length of documents and it also handles the saturation of term frequency. In effect, it fills up some of the gaps in the TF-IDF logic. In order to assist professional searchers in their complex Boolean queries, we also introduced two search helpers, the first one being semantic suggester and the second one being autocomplete. The semantic suggester looks at the query that you have entered and gives you semantically connected words from the corpus of patents. This allows you to include those words that you may have otherwise missed in your query. Autocomplete, by its very name, gives you predictions against the partial word that you have entered. We also combined autocomplete with synonyms that you can choose to then further include in your query. Our foray into natural language searching or paragraph-based search started with an algorithm that relied on lexical similarity. Lexical similarity, or as you can simply call it as keyword-based similarity, is as simple as the paragraph-based search would give you those documents that had higher frequency of words that occurred in your paragraph and also gave preference to the order of the words. A couple of years later, we then launched our first ML-based semantic search. And this semantic search relied on a rules-based approach, and the rules engine is what we call as ReliSense. This was an enhancement over our previous paragraph search in the sense that the system leveraged various rules to decide how the paragraph was to be interpreted. This ML-based approach also had its own limitations. And finally, in June of this year, we've launched our latest AI search, which is based on the transformer-based architecture. We essentially rely on a large language model that has been custom trained over patent data. We'll go deeper into this new AI search in the next slide. However, let me add that being an expert search system and adding an AI search that's based on the latest architecture, our intent has been to give you the best of expert plus AI. In this regard, we've also added a capability that allows you to re-rank your Boolean search results based on the AI engine, which we believe is truly unique and one of its kind in the industry. So if you've taken a look at the press release that we gave out when we launched the AI search, you would have come across terms like transformer-driven model, LLM-driven model, GPT-powered AI search. What do they all really mean? To clarify, GPT, first of all, is not ChatGPT or any service related to OpenAI. I'm putting this up front because we've got these questions, and I just wanted to clarify that your AI search does not go to any third party. Yes, it's true that the first GPT-based transformer was launched by OpenAI. However, GPT is a term increasingly given to any type of large language model, and these transformer models are essentially pre-trained on a large corpus of text, which would include things like Wikipedia and many other sources. How does the AI search differ with the previous two types of natural language searches that we had? The first and key difference between the new AI search and the previous one is that it considers the meaning and intent behind your query. This is what we call as knowing the context of your query. How does it do that? And I'm going to try and explain this in the simplest of terms. So the new AI search leverages what we call as text embeddings. These are essentially multidimensional numerical representations of the words and phrases and their relationships that exist in your input text. To put it in other words, these embeddings capture the semantic relationships between the words and phrases that are present in your text, and therefore they make for a much more context-aware version of the input. Now, in order to perform semantic search, we put all the patent documents that we have into a multidimensional embedding space. Now, by mapping the semantics of your input into this multidimensional space, it makes it possible for us to perform vector searches to find those documents that align closely with your input query. This results in faster and more accurate search results. So how is this better than traditional search methods? To begin with, it's all about result precision. By understanding the meaning and intent behind your query, the new AI search gives you more precise and contextually relevant results. Improved efficiency is the second benefit. By leveraging the learnings of large language models and also by using the text embeddings, it allows us for a faster retrieval of relevant documents, and this reduces the time taken to show you the results. Finally, it also helps us give you multilingual support. As you may have noticed, we recently went live with the capability that you can input a paragraph in any language. So here's a quick summary of how PatSeer's AI search differs from the older searches. The original natural language search had a rigidity issue. It could not handle keyword misspellings or even synonyms. There was no concept of intelligent retrieval, as there was no comprehension of the meaning or intent of what the input was. Further, domain-specific training was not possible because the underlying architecture did not support it. The new LLM or large language model-based search solves all the above issues. Further, it has been pre-trained on all the knowledge available on the web, and so the custom training that we have done on the patent literature actually leverage all the past learnings, and therefore it gives you a higher search relevance. Further, we also give users an option to alter the context awareness or the contextuality for certain cases where a keyword could be very important, for example, in case of chemical searches. We will go more into this type of a search later in this webinar. Now, before we move on to a live demo of PatSeer's AI search capabilities, here's a quick summary of the feedback that we have received so far. Overall, the feedback has been extremely positive and users are quite excited with the quality of results that they have been receiving. I will now pass the baton on to my colleague Ankita, who will go live into PatSeer and take you through the user interface and the various functionalities of the AI search.
Thanks, Manish, for the quick introduction. So first, let me just walk you through the PatSeer's user interface of this AI search. So to get a proper bandwidth, I will be switching off my cameras and we shall get started. Yes. So first thing, if you have any questions, then you can put it in the chat box of this GoToMeetings and we can answer those questions at the end of the webinar. So to begin with, this AI search is only available for our users that have our advanced PatSeer subscription, which is the PatSeer Pro X. However, we are currently providing a 3-day free trial for our other users to explore this AI search. And we have also included an advanced AI module package, which you can buy in addition to our existing subscription. So for more details, you can get in touch with our point of contact from our sales team. So here is the option of AI search. Once you click on it, here you will find two options to search based on text and patent. Here under the more option, you'll be able to see all the additional features that are present in PatSeer's AI search. So here, if you are a Pro X user or you have taken the AI advanced package, then this option by default will run on context aware high, which is basically the AI searching. You can also turn this option to context aware low, and the details of how this both options work can be accessed by clicking on this. So this context aware low option will look for lexical or keyword relevance, and the context aware high option will create a search based on the semantic or contextual understanding of the paragraph that you have pasted. Then further, you can limit your searches to a range of priority or an application year from 5 years to none. Then under the other option, you can further restrict your search to IPC CPC classes, current owner, priority country, or even legally active families. So I'll tell you how these options work as and when we go through our case studies. Then under the patent tab, you can create 3 types of searches, which is similarity search, infringement search, and invalidity search. Again, once I walk you through the case studies, I'll be able to give you more details as to how you can make use of these options. Now let's dive into our case studies that we have planned for this webinar. So the case studies that I will be showing you span across not only the text-based AI search, but we will also be conducting an invalidity search based on a patent number. Let's get started. So our first case study is creating novelty searches for patentability assessment. As you're aware, patentability studies are done to check whether a specific invention or a technology could be patented or not. So I have a paragraph with me which I would like to assess for novelty. This paragraph describes a solar powered lantern with a translucent plastic base which is made up of ABS. The lantern also has a photovoltaic panel on the top surface, a rechargeable battery, and an array of LEDs for illumination. The traditional way would have been to mark the relevant elements from the paragraph, which I've already done here. Then look for some synonyms or related terms for those elements. Then look for classification codes if required, and then prepare queries using Boolean or proximity operator. Now, by making use of PatSeer's AI search, you can simply put in the paragraph and let the system worry about the synonyms or related terms and even the contextual understanding of the paragraph. Now, let's run our paragraph in PatSeer. Yes. So, this is our paragraph. Let's run this search. First thing, this AI search will be showing you top 200 most relevant patent families. The score that you see here is based on the relevance that the paragraph has matched with the result set. Now, for demonstration purpose, I have already created a highlight profile for this particular technology. Let me quickly enable it. PatSeer's AI search provides you with the KWIC view, which displays what part of the patent text has actually matched with the paragraph that you have pasted. So this KWIC view allows users to quickly locate specific information within a large body of text. users can assess the relevance of a passage without having to read the entire patent document. The advantage of using this KWIC view while screening is that it saves time and effort in information retrieval tasks. Let's look at the first patent document by opening its KWIC view. So here D stands for description, and as you scroll below, you'll be able to see the claims or the abstract part, which is also matched with the paragraph that you had pasted. The patent text shown here in the KWIC view is sorted based on the similarity score. So this is the similarity score and this is the para sequence. Now, as you can see here, that this part of the description, it talks about a solar powered lantern, it talks about a plastic base, then a rechargeable battery, light emitting diodes, a photovoltaic panel. So all the key elements that are there in my paragraph have already matched with this part of the patent text. So the snippets really help you to understand which part of the patent has actually matched with the paragraph. Now over here you can clearly see that it makes use of a molded plastic which is made up of ABS. Then as you scroll below, it also shows you claims and so on. So this way you can easily locate which part of the patent is actually covering the aspects of the invention that you are searching for. Now let's move on to our second patent. So here also it talks about a lighting element, a solar powered lantern, plastic bottle, light emitting diodes, photovoltaic panel, rechargeable battery and so on. Now let's open our third record's KWIC view. Yes, so over here, so this particular record, it talks about a flashlight, but then there are also other aspects which are covered in this particular patent document, which is use of ABS, then it has a light emitting diode lamp, then it covers a rechargeable lithium battery, it talks about a solar battery panel and so on. Now the benefit here of using the AI search to get relevant results is firstly, it saves users time by providing more accurate results upfront. So this reduces the need to create iterative searches or even manual filtering. Then with this in mind, as you will be getting highly relevant top 200 patent families, there is a reduced risk of you missing out on any patent document that you may have missed while searching using Boolean queries. The reason being that this AI search's backbone is to give you results based on the contextual understanding of the paragraph and not just the keyword matching. So it is clearly visible from our first three records itself that the paragraph that I had pasted wasn't really novel. All the elements were covered and this could be easily denied a patent. Now let's move on to our next case study, which is identifying patent documents with technical similarities in a competitor's patent portfolio through AI search. So the topic that I have taken today for this particular case study is the flexible OLED technology. So I'm pretty sure that everyone is aware of this particular technology. It is basically a display technology that utilizes organic compounds which give you a superior image quality, and it is basically used in electronic devices like TVs or smartphones. So again, I have a paragraph with me which covers some aspects of this OLED technology, which is the panel, then the use of a flexible substrate which is made up of polyamide or elastic material, then an organic light emitting diode and a thin film transistor layer. So these are the important key elements that are there in my paragraph. Now I'm going to make use of PatSeer's AI search to create a search based on a particular competitor or a company. So currently I am interested in looking at what LG Corp has been up to in this flexible OLED technology space. So let's go back to PatSeer and run this search. Yes, so I have this paragraph here with me. Now under the more option, we have this option of restricting your search to current owner. Let's open our limit by option. So this data that is shown to you, be it the company names or even the IPC CPC classes, it's in accordance to the paragraph that you have pasted. So all these company names that you see here probably have a very good patent portfolio when it comes to OLED. Now, as mentioned earlier, I'm interested in looking at patents filed by LG Corp only. So I'll simply select this name over here and click on apply. Users can fully exploit this limit by option to specify their search query in the direction they are actually interested in. Then, be it by restricting your searches to one or more competitors or precisely to some IPC CPC classes. Now, let's run this query and check out our results. Again, I'm going to quickly enable my highlights. Now, let's check the current owner filter. So here you can clearly see that all these records that are currently displayed belong to LG Corp, and the other names that you see here are the ones with whom LG Corp would have collaborated. Again, the best way to check whether we have received relevant results is to see whether the key elements are matching with the results or not. So I'll open this record here. So this first patent document, it talks about a substrate being used. So it has not really mentioned polyamide, but it does mention polyamide in the description part. Then moving further, let's come back to the claims section. It talks about a thin film transistor layer, insulating filming layer, organic light emitting layer, and so on. So this particular document, it does cover the aspects that are mentioned in the paragraph that I had pasted. So I did this comparison based on the overlaps that was there between the paragraph and the key elements and the claims part of the patent document. And basically I did this analysis for the top 10 patent documents, and I have put it in a table for you to look at. So basically this is the table. Over here are the top 10 records. Then these are my key elements, which is flexible OLED panel, substrate being used, OLED layer, and thin film transistor. Then all these records belong to LG Corp, and these are the overlaps that I got when I compared it with the claims part of the patents and the paragraph and the key elements. So this is how you can create a search based on a specific competitor as well by making use of this AI search. And also, if not that, you can create a more focused search by restricting your query to specific IPC CPC classes as well. So this way you can direct your search with what exactly you're looking for, using the additional options that are present under the AI search. So for this particular example, I could clearly see that all the top 10 records either fully or partially covered the key elements that are mentioned in my paragraph. Now let's move on to our next case study. In this case study, my focus will be to showcase a very important feature that we recently introduced in PatSeer's AI capabilities, which is semantic refining. The benefit or advantage of having a refinement option in the semantic search is that you can create a more focused search based on the specific aspects of the technology that you're looking into, thereby reducing the time and effort of scanning through thousands of patent documents. You can select or add up to 3 records of interest from the existing result set, or you can also copy paste the numbers and you can run this refinement. So to demonstrate this, the topic that I have chosen is a coffee grinding brewing system, basically a coffee machine. So I have this paragraph with me which covers an autonomous coffee machine for production of coffee. It also mentions the machine to have a sensor, some reservoir, a heating tank, a controller, and so on. Let's go back to PatSeer and run our search. So I have this paragraph over here. Let's run this. Again, let me quickly enable my highlights. Yes. So as you can see that the first few records here mostly cover a coffee grinding brewing device, a coffee machine control device, automatic coffee machine, coffee maker, and so on. Now, I'm particularly interested in this 5th patent document, which covers the concept of control system for coffee machine with a wireless communication function. Okay, now here is the option of refinement. Let me just quickly select this patent and then we click on refinement. Now here, as mentioned earlier, you can add up to 3 records. Let's run this search. Now, as you can see, the records have been reordered over here, which we saw earlier that talked about a control system. So here we have this record which talks about a control device. Then moving further, this is the record that we had selected for refinement. Then as we go further, this also talks about the intelligent coffee towards bubbling system. It does have microcontroller, wireless communication. Then moving further, we have this coffee making system which does have a control module and then some communication system. Then let's move further. Yes, so I have this record which talks about the intelligent control system of coffee. It does mention wireless communication module, electronic control apparatus for coffee, and so on. This way, you can make use of a single or multiple records to create a refinement within your result. The point to remember here is, while doing this refining, it's not that the records within the data set are just getting reordered. An entire new query is getting formed in the backend. That is, a new search is created with the input paragraph and the record that you have selected. So you will see some new records showing up even when they didn't show up in the AI search that you ran. Basically, the results here are consolidated based on not only the semantic or contextual understanding of the paragraph, but also the records that you have selected for refinement. Now, let's move on to our 4th case study for today's webinar, which is semantic re-ranking for Boolean queries. So this semantic re-ranking goes beyond traditional keyword matching. It leverages advanced machine learning techniques to analyze the content and the context of the selected patent documents. Basically, semantic re-ranking involves elevating the ranking of specific records in the result set based on their semantic similarity to the chosen records or the free text that you're going to paste. This process significantly improves the precision and the relevance of the search results, helping users find patent documents that are more closely aligned with their specific technical needs. The process of re-ranking is the same as that of refinement option that we discussed before. However, the working of this both is completely different. As mentioned earlier, the refine option completely builds up a new query based on the paragraph and the selected record, while this re-rank option helps you elevate those records that are contextually matching with the selected records and are displayed to you first. The importance that re-ranking plays when you're running Boolean queries is that, firstly, it is restricting your result to up to top 500 highly relevant results based on the selection that you have made. And secondly, as the results are restricted, the time and effort to manually go through thousands of patents just to get a subset of records that are actually relevant for your search is reduced to an exponential level. Meaning, the time required for you to complete a single project which is assigned to you by your higher authorities, it gets reduced by half. Now, with this in mind, let's look at our case study. The topic that I have taken for demonstrating PatSeer's re-ranking is a shape memory textile and its application in biomedicals. So the shape memory textiles are innovative materials which are designed to change and retain specific shapes when subjected to external stimuli like temperature variations. And it has a wide range of applications like smart clothing, medical devices, and beyond. Now I have this query with me which I have designed to retrieve patents related to shape memory polymers or shape memory textile in the context of medical or surgical applications. I also aim to find patents that involve these materials in conjunction with the medical devices or various medical apparatus like stents, catheters, dentures, screws, etc. Now, let's go back to PatSeer's and see how we can make use of this re-ranking option. Yes, so I have this query here. Let's run this query. So for this particular query, I'm getting results which are like odd 1500 simple family members. Now, just like refinement, when you are scanning through the patents, you come across a number that is highly relevant and matches with what you have in mind. So you can simply select that record like this and you can go to this re-rank option, and over here you can see the record that you have selected. So this re-rank option helps you to create a search based on a paragraph as well. So over here you can simply input the paragraph that you are interested in regards to the same technology obviously, and based on the aspects that you have mentioned in the paragraph, the elements, you can re-rank your results and get the highly relevant results at top. So for this demonstration purpose, I have taken a patent document which specifically talks about a shape memory nasal stent and its preparation method. Let me just quickly paste that number here. So under the re-rank, I'm going to paste this number over here. So as mentioned earlier that I have this number which talks about a shape memory nasal stent and its preparation method. And the other concepts that are mentioned in this particular patent document that I wanted to focus on is the different types of materials used, the drugs that are loaded within the stent, use of 4D printing method for the preparation of the stent, and so on. So let's just run this re-rank. Again, I have created a highlight profile, so let me quickly enable that. Yes. So this is the first record which I had selected for the re-rank option. So I'll just open this and I'll show you the elements that I was interested in. So yes, I was interested in a shape memory nasal stent. Then I wanted to focus on these materials that were used to prepare this. Then the drugs that were loaded. So we have different types of drugs. Then use of 4D printing method to obtain this nasal stent, and so on. Now let's move on to our second patent document. So over here, yes, our second record also talks about the shape memory polymer which is loaded with drugs that is used for nasal or sinus support. Then as we move further, it does talk about the materials that are being used. Then it mentions the use of drugs. It does talk about immunomodulators that are used, which is mentioned somewhere in the description. Then it also talks about a printing method, which is again in the description part. It has mentioned the use of 4D printing and so on. So this way you can make use of this re-rank option to get those results which you're actually wanting to more focus on. Let's move on to our last case study, which is conducting an invalidity search against a patent document. I'm sure we are aware that this invalidity patent search is a comprehensive investigation that is conducted to identify prior art or existing knowledge that would potentially invalidate a patent. So the example that I'll be taking here today is an infringement case that was filed on 10th of July 2015. The plaintiffs was the company called IPS Group Inc. and the defendants were Duncan Parking Technologies. So the technology that was covered in these patents was a parking meter with some sensors, rechargeable batteries, solar panel and so on. So we looked for patents filed by Duncan in the same technology space to create this invalidity check. And we did this analysis to see whether PatSeer is showing up the records filed by IPS group as a prior art. Now let's go back to PatSeer and run this invalidity search. So here under the AI search, we go to the patent tab, we paste our number here and I click on search. So as mentioned earlier, this patent tab or AI search based on a patent number, there are three types of searches that you can create, which is a similarity search, invalidity search and an infringement search. So for similarity search, you can copy paste up to 5 numbers which are separated by a comma, and invalidity and infringement search can be done for one single document only. Here also under the more option, you'll be able to see how your AI search is running. So we have this context aware option. Then you can further limit your searches over here. So this is for similarity search. And under the other field, you can further restrict your search to current owner, priority country and alive families only. Now if I select invalidity, the limit by option of earliest priority and application here is not going to be shown. Instead, you can select a cutoff date. So this will be based on this particular, the patent number that you have pasted. So I have this number which has a priority of 2013. So I'm going to select the cutoff date as earliest priority date and I'm going to run this search. So as mentioned earlier, I have this record which is filed by Duncan Parking Technologies, and I'm going to see whether PatSeer is actually showing me records that are filed by IPS group in this particular search. Again, let me quickly enable the highlights. Okay, yes. So the easiest way to check whether we have a patents filed by IPS is to look at the current owner list. So yes, over here I can clearly see that there are 5 records which are filed by IPS group. I'm going to filter this records. Yes. Now over here I can clearly see that these records, there is a litigation icon. So I'm going to click on it to know more details. So as mentioned earlier, this patent was under an infringement and this was filed by IPS group, and under the defendants we can see Duncan Parking Technologies Inc. and so on. So this way, this invalidity search gave us the patents that were filed by IPS group as a prior art by using PatSeer's AI search. Now just to do a comparison between these patent documents, I'm going to run these patent documents in the number search and we can see how there is a overlapping that's happening. Yes, so I have these two numbers. So this is the application number that was filed by Duncan and this is the granted patent document which was filed by IPS group. Now just by looking at the image itself, we can see that yes, they both cover a parking meter that is used. Then there is a mention of solar panel. This also talks about a solar panel. Then there is a coin or a card slot. Then this particular patent document, I'll just open it. Yes, so even this particular number talks about a vehicle sensor, which is also mentioned in this particular patent, and so on. So yes, these two numbers, they do have overlaps when it comes to the technology, and this is how you can make use of this PatSeer's AI search, especially infringement and invalidity search, to see which all prior art is showing up. Then just to cross verify this, we did run this granted patent number of IPS group in the infringement search of PatSeer to check whether we are getting records filed by Duncan Technology as well. And yes, we could see that we were getting records that were specifically talking about the sparking meter, which were filed by Duncan Technologies. So this is how you can make use of this infringement or invalidity search to create a more focused search based on a single patent document.